Hello and welcome back to Hydroponics Daily, your go-to podcast for everything soilless cultivation. I'm your host, Dr. Russell Sharp, and today we're talking about a very important environmental variable that is often overlooked, and that is the red to far red ratio in your grow room or your greenhouse or anywhere where you're growing plants. Often we think about light levels, but the light quality is very important. So we're going to do a deep dive on the red to far red ratio, which scientists have discovered is very critical in how plants grow. And it's why some grow lights are ideally suited for growing basil, whereas those same lights are terrible for growing things like legal cannabis. So we'll explain more in more detail. I'll explain more in more detail as we go along. Often you'll see lighting manufacturers oversimplifying things, saying, it's got high blue light for compact growth or red light for photosynthesis. But it's actually the ratio of red light to far red that's more critical. It's often abbreviated to capital R, capital F, capital R, so red to far red ratio. It's critical for steering your crop development, and often you're hearing a lot more about crop steering in many different crops. So plants perceive light not just as energy, like the chlorophyll absorbs it and it photosynthesizes, but more specifically, they have photoreceptors that sense the surroundings. And the most important one is a group of pigments called phytochrome. And phytochrome is not involved in photosynthesis, in harvesting it, but it does absorb red light and far red light. It's a pigment that absorbs both and can switch its structure depending on which one it absorbs, and then that stimulates metabolic processes and signaling further around the plant. So as you said, the red to far red ratio can tell a plant if it's full sun, if it's shaded by other plants, if it's near the sunset. So high red to far red means open daylight, no shade, and more far red signals competition because the red will have been absorbed by the chlorophyll and as it goes through the canopy, and so the plants will receive more far red than red. And so a shaded plant will grow differently to an unshaded plant. It will have thicker leaves, bigger leaves. It will grow many plants, it will grow long and spindly to get out of the shade. Or it can be a sign of dusk. There's much more far red at dusk. And so plants perceive that it's now coming to dusk and it's going to go night soon. And so that can be a critical signal as well. So the red to far red ratio at the end of the day length can be important. So they can change a growth strategy of the plant. In a greenhouse or a vertical farm, we're not limited to just the sun spectrum and the light coming through canopies and things like this. We can adjust the red to far red ratio. It used to be the case back when I was doing my PhD that really the only way of doing that was through filter films. So you could have polytunnels with different filters on, or glass with different filters. Glass with different filters was very expensive, and the polytunnels were not much. Well, they were cheaper, but they weren't as good. They only mildly affected the ratio of red to far red ratio. Whereas now you can get lights that just have the one wavelength that you're interested in emitting. So I've got some lights in my grow room that are just red at 660 nanometers. And you look at their spectrum, the peak is just at that one wavelength, or just at far red, or just in the blue. So you can massively change the red to far red ratio. And it's not just red light in general that you have to be careful. It's those one specific wavelength, 660 and 720 to 730 for far red. So they're specific wavelengths. It's not just red in general. That's important to note. So if you're looking at a light spectrum, then look at 660 and 720. Okay. Supplementary LEDs you can manipulate them and you can change the LEDs. So grow lights now, you can really have a massive effect on the red to far red ratio, and include blues for compact growth and greens to open stomata. So there's a whole host of other things you can do with the spectrum. You can still use selective grazing or inter canopy lighting or under canopy lighting as well if you're looking to increase the plant height, such as increasing far red, or by reducing canopy height by having red light. So as opposed to using growth regulators and things like this. So light recipes, you'll often hear referring to light recipes. Depends on the crop you're growing. So if you're growing lettuce and leafy greens, too much far red can cause excessive stem elongation. So not what you want if you want a marketable head of lettuce. However, if you're growing basil, especially if you're growing microgreens, as I'm growing at the moment, you don't want them to be too short because the compost or the grow media will get in the way of cutting them and they won't look as big. So you want more far red in one where you're growing basil. Tomatoes and cucumbers, far red can improve light penetration, canopy structure, can accelerate flowering as well. And then in ornamental crops, flowering in species like petunia and chrysanthemum can be strongly enhanced by end-of-day far red treatments. So a flowering crop, you can get better flowering by just giving us a spurt of far red at the end of the treatment. And then perhaps one of the most critical and powerful demonstrations of the importance of this is seeds and germination. Certain species use phytochrome status as a germination trigger. So far red light inhibits germination and then red light promotes it. So if you get a lettuce seed, normally things that promote plants need to germinate, it's oxygen, moisture and warmth. You give them all three, they'll germinate. But in some plants, they need light as well. They are photoblastic. I think that's the word. I've not Googled that, just off the top of my head. And so if you give lettuce plants far red and then put them in the dark, they won't germinate. But if you give them red light and then put them in the dark, they will germinate. And that's because the phytochrome has been activated. So that's really powerful. And that's the way that phytochrome was discovered. And then we found out about things like its effect on stem elongation and flowering later on. So recent research has shown that far red is not just a signal, but contributes to photosynthesis as well. So by extending the use of light spectrum through what's called the Emerson enhancement effect, far red photons can increase photosynthetic efficiency when paired with red light. So we used to think of it as just being this useless wavelength that wasn't actually useful because we can't see it really with our eyes. Far red, you can just about see it. It's not invisible to the naked eye, but it's pretty dull. We don't perceive it very well. I think one of the areas that can really be exploited and probably could be exploited in the next few years by growers is end-of-day far red treatments. Giving plants a short pulse of far red at dusk. It used to be really difficult to do this, but now it's really easy with modern LED lights. You could even have a grow light that was triggered to do this automatically. So you could, especially for flowering in long day crops, promote elongation in young transplants and reset phytochrome status to mimic natural dusk. So you can much more natural growing conditions. So obviously it has to be applied carefully. Lettuce growers, for instance, you want to avoid that, but for basil crops could be a good one. And I think this is where I struggle when you see a lot of LED grow lights that are marketed for legal cannabis growers or tomato growers for indoor growers that contain far red light as a benefit. And I think, why would you want far red light in that light, on that light? Because it's just going to increase stretch and the grower is going to be reaching for the growth regulators. And I think we should be avoiding the use of growth regulators. So maybe I'm not a light manufacturer. Maybe they found in studies that actually produces a better crop. I don't know. But for me, it seems a bit counterintuitive to include far red light in LED grow lights for grow tents. And probably that's been borne out by the fact that one of the main companies that did include far red has now gone out of business. So let me know your thoughts on the inclusion of far red lights in lights for indoor growers, especially for legal cannabis growers, because that seems a bit bonkers to me. So we said that phytochromes are the primary sensor, and then downstream effects involve changes in auxin distribution, one of the key flower hormones, gibberellins and transcription factors and things like this. And these cascade and change stem elongation and leaf expansion, flower initiation after that. So that's been Hydroponics Daily for today, the red to far red ratio. I might do another couple of podcasts about spectral quality, the use of green lights as safe lights for going into your grow tent when you're trying to produce short day lengths, and the effects of blue light and green light on photosynthesis and plant growth. That should be interesting as well. Okay, thanks very much for listening, and I'll see you again tomorrow. Goodbye.